Hello and welcome to our next webinar with the topic Tips around ABB IBAS KNX. Yeah, my name is Thorsten Reibel. I'm sitting here together with Jürgen and we will share this webinar. Let's have a look to the agenda. First of all, in total 8 topics today. First one is the parallel operation of KNX presence and motion sensors. Always questions around this. We would like to make it a bit more transparent. And then the topic unified RTC with 2 independent controllers. You might know that with our new RTC components we have some more options in the software I would like to explain. Then the topic bus cable, standard in principle, but also here always any questions come up and we would like to make it also a bit more transparent here. Scene management, scene control. Then will be done by Jürgen, followed by the status of LEDs in push buttons, for example, also interesting topic. Then the sending of the first group address of a group object. Always here questions also in our trainings here in Heidelberg, so we would like to talk about this as well. Then the topic area coupler, and line repeater, especially line repeater will be the topic. And last but not least, we have at the moment a bit sensitive topic about KNX or building automation. How safe is installation and communication? Also here we would like to give you some more information and some hints. Good, let's start with the first topic, parallel operation of KNX presence and motion sensors. Let's go directly into a practical situation. For example, you have a corridor here with some lights operated together, and due to the size or the length of the corridor you need more sensors, either motion detectors or presence detectors, to cover the whole area here. So you have to operate sensors in parallel together with the actuator operating the light. So if you do it the traditional way, okay, you have one light circuit and all sensors and actuators are assigned with the same group address, like normal parallel operation of any push buttons, for example. What would happen? First of all sensors have the same light on time or delay off time you adjust there. So what happened if you reach the first area, for example in sensor 1, of course, light will be triggered, switched on. Then you go to the next part in your corridor, to the next detection area of the sensor 2. What happens? Of course, the sensor 2 will re-trigger the light, but sensor 1, programmed with light on time or delay off time, will after this time switch off the light. So though you are still in the corridor here and light will go off, you are confused a moment, then you move again and then light will be switched on again by re-triggering by means of sensor 2. So this is of course a situation we don't like to have. Switching off of the light in between is not good. How to resolve this problem? There are 2 options to do this. Solution 1 is the following, that you send from the sensors, motion or presence detectors, only cyclically on telegrams in case of detection, of course. So no off telegram after delay off time or light on time. How to switch off the light anytime? The actuators have to be parameterized with a staircase lighting function. Important is that the cycle time of the sensor is shorter than the staircase lighting time of the actuator. Otherwise you have these uncomfortable effect that also the light will go off in between and you have to switch it on by movement again. So what does it mean for our parameterization in the ETS? I show you here an example with an actual or current presence detector. So what you have to adjust here, it's a master, not a real master, but in principle all these sensors in this case are masters. They need no slave inputs. We do it in the next solution. Output object sends at switch on, so in case of detection of movement, and on telegram. And cyclical sending. Cyclical sending every minute, of course. So then for the staircase time of the actuator, of course you have to adjust here time as well. In this case it has to be greater than this 1 minute time of the sensor. and we have to adjust, for example, 2 minutes here. So after 2 minutes, no movement, the light will be switched off. Yeah, and for the communication or group objects, it's very simple. I have, I show you here only two motion, or in this case, presence detectors in parallel, but it's very simple. Both have the output with the same group address, 111, cyclical sending on, and the switch actuator in this case receives this group address, and with the staircase time it will be switched off. That's a more or less traditional way to do this, and should be possible in almost every case. Of course, you need a staircase time function in your actuator. That's condition. In a switch actuator, no problem. If you have a dimmer, for example, you have to do it externally or however. So, and the solution 2 is the classical or the real master-slave constellation. What does it mean? The same situation with the corridor I have just mentioned, but the 3 sensors, presence detectors or motion detectors, are programmed differently. One sensor has to be the master, and the others have to be the slaves. How is it parameterized? The master will send an on telegram in case of detection of movement in its detection range. If there's no detection, an off telegram will be sent after this light on time. So the master is in principle responsible also for switching off of the light. The slaves are differently programmed. In case of detection, they send on telegram, but cyclically, to the group object slave of the master. So there's a communication between slaves and the master. In case of no detection anymore, there will be not sent any telegram from the slaves. So if there is no movement at all anymore, neither in the master or nor in the slave detection area, then the master sends an off telegram after this light on time to the actuator, and of course light will go off, what you would like to have. Concerning parameterization in the ETS. So our master presence detector in this case will be programmed as a master, but also the input slave, very important to communicate with the slaves, has to be enabled, and also in a further parameter, the light on time here in this case 5 minutes has to be adjusted. The slaves, presence detector slaves in this case, are slaves, adjusted as slaves here in the parameters, and have this cyclical repeating time 30 seconds in this case. And important also here, the cyclical repeating time of the slave has to be smaller than the light on time of the master. We see in the next slide the group objects, the slave input of the master, for example. And these objects, slave input, is in some other components called extension unit input, for example in the solo motion sensor. Only in other wording, but the same principle. So if you have a look to the group objects, again 2 presence detectors programmed here, the master 5528 and the slave 5529. So the master sends out on his output, if detection is detected in principle, or a movement is detected, a telegram to the switch actuator to switch on the light. If no movement is detected anymore, it will switch off after the light on time. And the slaves, they send cyclically, if they detect something, to the slave input of the master. Okay, there is some movement, and the master will be re-triggered in principle. So another way, I think in all of our presence or motion detectors, this way of parameterization is available, and it's a classical master-slave concept. Good, that's are these 2 solutions around this. Allow me to come to the next topic, the unified RTC with 2 independent controllers. So what does it mean? You might know that our room temperature controller are started already some months ago, more or less updated to the so-called unified RTC concept, which is not only software, also new hardware, but mainly it's an improvement in the software. And what does it mean? You can program there two different controllers in principle. So, or you can say there's a basic stage available and an additional stage, but with individual control parameters, yeah? Both for heating and also for cooling. Yeah, an example for this option is you have a room with cooling ceiling, for example. It's a basic stage for normal cooling, but in case of a request of strong cooling, you have an additional fan coil unit in the room, and this is an additional stage and has to be controlled independently. So we talk about the same room. We have only one room thermostat with one room temperature detection, but two independent controlling outputs. But you will see later on in principle 4 if you take both heating and cooling. Yeah, another example here, a floor heated bathroom, basic stage, but you have an additional towel rack in this bathroom used as an additional stage. So finally, what does it mean? We can have one or two set points, depending on our adjustments for these two independent outputs, controller 1 and controller 2, with each individual adjustments. But I will show to you how it works in principle in the ETS programming. Here an example of one of our unified RTC parameters. First of all, the control function can be heating or cooling, you know this. Can be both heating and cooling if necessary. And all of these additionally with an additional stage. So here I have adjusted now heating and cooling and additional stage for both. So what does it mean? For the basic stage, you can adjust the control value type, 2-point control, pulse width modulation, fan coil control. And the same independently also for the additional stage. So it looks the same here, but there are two different parts in the parameters where you can adjust both independently. And then you go for each of these basic stage and also additional stage to further individual parameters here, what kind of control parameter you would like to have. And this parameter here, temperature difference to basic stage, I will explain in the next slide. And finally, coming to the group objects, you will find here 4 individual outputs if you have both heating and cooling, because you have a basic stage and an additional stage. So in this case, 1 byte outputs maybe for fan coil, for example. So on this parameter, temperature difference to basic stage has nothing else to do but with this 1 or 2 set point explanation I have given to you already. The set point temperature of the additional stage is defined as a difference to the basic set point. The basic set point you adjust in the parameters, and with this temperature difference you adjust in principle the set point of the additional stage. So this value represents the set point at which the additional stage starts to operate in principle. And in the next slide I show you for heating the set point for the additional stage is higher, for cooling it's lower than the basic set point. You can adjust this difference to 0. What does it mean finally? You have no different set point for additional and basic stage, so you have one set point only. It's also an option, but you can control 2 different circuits with 2 different adjustments here in your room if necessary. Yeah, and you see it here a bit more transparent. If you have for cooling, for example, a base set point of 22 degrees, you adjust this temperature difference to 20, then you have here a set point for the additional stage of 20 degrees. So if there's a request for getting 20 degrees or less in the room, then the additional stage for cooling will be active here in this case. And vice versa for heating, base set point is lower than the additional stage set point because you would like to heat. But the same principle. Yeah, and this basic load, for example, floor heating system, you can say, okay, I would like to have it active all the time with a minimum control value, in this case less than 10%, to have a basic warmth on your floor heating system, for example. But it's also possible to switch off or disable this this basic load via communication object. So you can switch it off, for example, during the summer, where you can say, okay, it's really warm outside, I don't need any slightly heated ground anymore, so I can switch it off completely. Either possible here. So you see you have some more flexibility with this unified RTC for independent controlling of different circuits in the same room. That's the message here. Yeah, and a further part I would like to explain is the topic bus cable. What we can say about bus cable is it's a bit. There are still some questions all the time in the last years about bus cables, so we try to show you a bit here around this topic. As you know, it's also not free what you can use here for the bus cable for a safe communication. So the KNX organization also defined what is necessary or specified what is necessary around the bus cable. And there exist approved bus cable on the market. They have no KNX logo, but also certified bus cables. So you will see later on the KNX homepage there are also an overview of certified bus cable available or visible for you. So you need this standard KNX twisted pair cable because we have maximum cable length in one line to observe. We have a maximum distance between two bus devices in a line, and also of course a maximum number of components per line. And a bus cable, it's a copper cable in principle, which has to do with resistance and also with capacity. All these things are influencing the safe communication on the KNX bus cable. We have a shielding in these cables, these KNX cables. You don't have to connect anywhere. So it's really not necessary. Very simple. You will see it's only the two wires we have to connect for communication. Here the overview of these cable lengths in one line, distance between the components and distance between the power supply in one device, necessary to fulfill, to have a safe communication in all cases, of course. As you know, we have 4 wires inside this KNX cable. We use a red and the black one to connect to each KNX device. Red for plus, black for minus. The spare wire pair, yellow and white. How to use this? Normally not in use, in most of the cases. It's allowed to connect any extra safe extra low voltage, for example 12 volt, to supply our security terminals for security applications, the typical application, or to supply if you have a Prion push button in your installation, and in some special situations you need a so-called bus coupler with external power supply 24 volt. You can use also here the yellow and white wire. It's not permitted to use it as a normal KNX communication cable for another KNX line. That's not the target of these yellow and white wires. So in the recommendation, if you have an installation, maybe in a main distribution board, where a lot of lines going to the field, because you have a lot of line couplers, for example, it's recommended to label, of course, also these bus cables, which line is behind, for example. So, which kind of bus cables are available on the market? They are very similar. YCYM 2x2 0.8, more or less for indoor, or mainly for indoor installations. You see here some limits for this cable. Also outdoor possible if it's protected against direct sun radiation. Test voltage 4 kilovolt. And the other one, JYSTY 2x2 by 0.8. Same principle. Also possible in outdoor installations, but with a lower test voltage, 2.5 kilovolt. These are the standard cable. And you see here again, the standard cable with green cover, let's say. As mentioned, if you go to the KNX homepage, you might know that you see there, or you can see there, all the certified KNX products. An overview of this bigger number of products from different manufacturers. And if you look there, there are also manufacturers of cable visible here, which have certified their KNX cable. For example, here is one company, FS Cables. They have numerous cables available, and if you look on the homepage of this company, you will see different types. And you see it's not only green cover, but also black and white is available. So it's not mandatory to have green cover, but also other colors are available and allowed and on the market. Good. So just some more information about this standard bus cable. I would hand over now to Jürgen, continuing with the topic scene control. A moment, please.
Hello and welcome to the second half of this webinar, Tips around ABB iBus KNX. My name is Jürgen Schilder and I'm continuing this webinar. So let me start with the first topic, scene control. Yes, at first the question, what is a scene? A scene, with a scene, for example, we can put a group of lamps, shutter, blinds, fan coil units or other devices into a desired operating state. It can be, for example, the lamp on, off, set to a value 50%, different kind of colors of the LEDs. The fan coil units go to comfort mode or standby mode, and all this happens by a defined action. A defined action, for example, can be a KNX telegram, or it is one KNX telegram sent by, for example, a motion detector, a push button, operating element, or also a security panel. For example, when we have intrusion alarm, then we call a so-called intrusion scene, switch on all the lights. Some lights are starting flashing, maybe in the room where is the alarm, and a lot of other things are now possible. So with such scenes, they can be, for example, used in a, like here, in a meeting or in a training room as a welcome scene. So now the trainer goes in the room, unlocks the door, opens the door, and start a kind of welcome scene. So all lights go on, the fan coil unit goes into the comfort mode, the shutter or the blinds drive in the position up, and the music goes on and plays some sounds. And now when he starts the presentation, he presses again the next button on the next side of the rocker to start the presentation scene. The lights in the front area goes off, maybe in the middle of the room up to 50%, and in the background we have also still some lights on. The shutter or the blinds drive in the position down, music goes off, and the presentation screen drives in the position down, and the presenter goes, the projector, for example, goes on. Next time we have the coffee break, then he calls the coffee break scene, all lights go on, the ventilation system goes to the higher speed, for example, music starts playing and so on. And until he reached the end of the meeting or the end of the training, he calls maybe the end of the meeting scene or the goodbye scene, and all lights go off, the shutter drive in the position up, the projector off, and the presenting screen goes in the upper position. So all these things maybe can be happen in a lot of comfortable way by using this different kind of scenes. We have three possibilities to realize these scenes. So the first one is we use another kind of scene controller. This was in the former times. At the beginning of the EIB KNX systems, we have the sensors, the actuators, and we need additional logic like the scene controller. So today we can still use it by using our so-called logic module LMS. And now some years later, the manufacturer of the sensors integrated this scene function into the sensors. So today it is quite common to use the scene or to store the scenes in a sensor. And the manufacturer of the actuators have also integrated the scene function in the actuators. So today we have two possibilities: to use the scene function in a sensor or to use the scene function in actuators. And now I show you all these three possibilities, and I think the best solution is, later you will see, is to store all the scenes in the actuators. So here is the first solution. We store the scenes in an additional piece of hardware, which is, for example, our logic module, our so-called scene controller. So we need a sensor. It can be a control element, a push button, motion detector, or device like you want. Then we press here one rocker, send one telegram, one KNX, 1-bit telegram to our scene controller, and the scene controller is now a kind of multiplier. He sent maximum up to 6 telegrams, that's why we talk here about 6 actuator groups, 6 telegrams to our KNX actuator. So one telegram comes in and he answers with 6 telegrams with the value on, off, 50%, up and down, for example, or temperature value. And all these values are now stored here inside our scene controller. Later you will see in the parameter, we can here select scene number 1 and set as a default value our 6 useful data on, off, up, down, 50% and so on. So this is the principle by using this scene controller. Let's go here in the ETS application of the logic module. So the logic module, we have the possibility to use one feature, the so-called scene feature, like here for example in the function number A. So then we get automatically here our maximum 8 scenes. So we have here on the left side, and then per scene we can at the beginning we have to define the data point type of our maximum 6 telegrams which a device can send to our actuator groups. For example, the first one is a 1-bit value, the next one is a 1 byte value, 0 to 100%, also 1 byte value, 0 to 255, or a temperature value. So this is the first step. We have to define the data point types of our 6 telegrams which will be sent to the KNX bus. So and then you see here the group objects, our 6 output telegrams, and here the lengths 1 bit, 1 byte, up to 2 bytes. And here we have our incoming group telegrams to call our different scenes. So here we call the scene number 1 and 2 depending on the value. If the telegram here has the 1-bit telegram have a 0, then we call scene number 1, and with the value 1, which means on, then we call scene number 2, and so on. So we can call with these 4 objects up to 8 different scenes. So on per scene here we define the values which will be sent to the KNX bus. For example, when we call scene number 1, and then the output, the KNX actuator group number 1 sends the value on, number 2 10%, for example here the 1 byte value 280, and here for example 21 degrees, and here 10%, and so on. So per scene we can here set these default values. Good, the next step, the next more comfortable step is to use the scene functions in a sensor. So today nearly all kind of sensor, for example the universal interface, USU, or here our control element, the Prion, the Comfort Touch, all these devices have the scene function inside. So but here we have in principle the same, the numbers of scenes are now limited. So for example our standard control element, the solo sensor, can send up to 8 different scenes. He uses up to 8 different scenes, and we have maximum number of 8 telegrams he can send to the bus. So here we have built inside the scene controller like I explained you before. So one feature is when we press short, then we call the scene. So the sensor sends this maximum 8 telegrams to the bus and calls our scene, including the value. So the value on, off, 50%, 21 degrees is now transmitted to the bus. So we have 8 KNX telegrams on the bus. A nice feature is, for example, to allow the customer to store the scenes. So with his standard push button he can drive the shutter in a position, he can dim, darker or brighter or switch off, and then the end user can press long one rocker. So long means the sensor now send a command, a read request to the actuator, and the actuator responds with an answer telegram. And this answer now, the actual status, is stored in the sensor in our scene control element. So this is a comfortable function. It's not necessary, we can enable the end user. In principle, this is a nice feature, the scene function in a sensor. However, we have more bus traffic. So when we call a scene, we have here more telegrams. We have 8 telegrams on the bus. And the limitation is the number of scenes and the groups per element. So, and when we use the scene function in different sensors, we have a lot of scenes in this sensor and another sensor, and maybe some of you will use now the overview, where are all my scenes, for example, stored in which devices. Here you can see this principle. We have a residential apartment. Now when we want to leave the building, we press one rocker and we send a command, a so-called goodbye scenario. All lights should go off and some of the lights should go on, for example 30%, and some shutters should drive in a position up and down. So we call here our scene, we press the rocker, and then he sends up to 8 different telegrams, including the useful data, so the value, 50% up or 30% up, down, on and off. And the devices now are listening to these group addresses and do this command. So let's go to the parameter. At first the sensor. So we need a sensor with the scene function, like here our control element, our solo COM4 switch sensor. So the left, at first we start with the parameterization of our rocker 1, the left side. So we select here the mode one button light scene extension unit. So and then we get on the right side here our parameter to say the number, we can define the number of the scene. With one sensor we can call up to 64 different scenes. So we say, for example, we want to scene number 1, and here above we can define, or we can enable a parameter that the end user can also store the scenes. So we have to activate here this function, storage function, and the time for storing. So when we press short, less than 5 seconds, the sensor sends a command, calls the scene, and longer than 5 seconds, he sends a command, a read command to the actuators to read out the actual value. And then maybe with the next element, our rocker switch right, we can call another scene number 2, 3, 4, and so on. Let's go to the scene function. So we have to open here the additional view, the general functions. We enable here the light scene actuator, and then we get here the possibility to enable the number of the scenes. For example, here on the right side, we can enable maximum 8 scenes. And each single scene, for example, exists here of up to maximum 8 actuator groups. So when we call later the scene number 1, and then you will see here on the left side, he sent 8 telegrams to our KNX world. The next step is, when we have activated these maximum 8 actuator groups, we can define the data point types of these 8 outputs. For example, 1 bit for shutter, for blinds and lamellas, and the 1 byte here for sending a dimmer to a defined percentage, and a temperature. So for all these 8 actuator groups we can define the data point types. And if you want, additionally here a time delay between sending the telegram. So now when we call a scene, then he starts with the first actuator group, 1 second later he calls the next actuator group, the next. So we can reduce the time of the telegrams. Good, and then the next step is we have to go to our scene number 1 and set here the parameter which value should be transmitted. For example, here the actuator group number, actuator group A, the value of B, for example, this is for shutter driving up. Here the percentage, 65%, maybe brightness value in a dim actuator, and here, for example, actuator group D, 20 degrees. So for maximum all of these 8 actuator groups we set here the default value. And when we go down, then we can set also default value for the next scene, which is maybe scene number 2, 3, 4, up to maximum 8 scenes. Now when we have a look here on our group objects, so at first we get a group object of the rocker, left side and the right side. We have set here a parameter to call the scene. So we have here to link a group address, for example 0311. And we have here the input of our scene controller, which is here channel 0, number of lights in. So we have to link the rocker here with the input of the light scene. So and then the scene controller inside the sensor answers here with our maximum 8 telegrams to the bus. So we have to assign here maximum 8 different group addresses. Good, when we have a look at our group monitor, you will see here the telegrams. Now we press here our rocker, which is here the first telegram. Then he calls the scene number 1. But in our bits and bytes world, we start from 0. So all scene numbers are now shifted by 1. So when we talk about scene number 1 in our KNX world, in the ETS parameter, we have on the KNX bus the value 0. And when we say, okay, please call scene number 23, then we have on the KNX bus the value 22. All figures are shifted by 1. So, and then the scene function inside our sensor responds and send here maximum 8 values to our KNX world. So I think this is a nice feature to have the scenes in the sensor, but we have a lot of bus traffic when we call our different scenes. So a more, I think, recommended solution is to use the scene function in the actuator. So we have a very big advantage, which is that we send only one telegram, which is a 1-byte telegram. And with this 1-byte telegram, we call or we store the scene in the actuators. And this telegram or this group address is linked to maybe one of 1000, 2000, not limited number of KNX devices. So by pressing one rocker, we call one scene to do a lot of commands or situations in our building. And now nearly all KNX actuators, if it's a switch actuator, a shutter, DIMM actuator, DALI gateway or other devices, can listen to these 8-bit scenes. And this 8-bit scene is also a KNX data point type. You will see it later. So how does it work? So we need a sensor, also for example a control element or universal interface or motion detector, which can send a 1-byte telegram, because the scene function, the actuator, is working with 1-byte telegram. So we press here our rocker. We have defined left side of the rocker. For example, we want to call scene number 8, and then he sent one telegram with the number of the scene. The device does not send the value on, off, up, down 50%. He sent only one telegram, which is call scene number X, for example. And all KNX devices which are linked with this group address follow this command and looks inside their own memory inside, and inside we have the value. So and then, for example, when we call the scene, DIMM actuator, channel A goes to 30%, here the channel B goes off, the next one go on, shutter 80% or up and down. So there's a difference. We send only one telegram and call the scene. So, and the next advantage, we can also store the scene. So for example, with a standard push button here or with your sensor, we drive up and down the shutter and the blinds or dim the light, and then the end user presses here long the rocker, and then the device sends a telegram, store the scene. It's only a store command, and then the input A of the DIMM actuator stores here his new value 75%, and the next time when we call the scene, he uses this value 75%. It's also very nice that the end user here can change maybe the behavior of his scene. Sometimes maybe between summer and winter he wants to have different scene situation, and then he can store the new scene values. So advantage of this 8-bit scene is we can call and store with one group address. We have not to use different group addresses. With one group address we can call and store up to 64 different scenes. And in this 8-bit telegram we have 8 bits. 6 bits are used for the number of the scene. That's why we can call 64 scenes. 1 bit is not used, is spare. And with the last bit, for example, we send the command call or store the scene. This is the explanation of these 8-bit telegrams. So, and what we have to do in our outputs, switch actuator, DIMM actuator, shutter actuator, we have to enable the parameter, say you are listening to the scene, which number of the scene, and the value. And here you can see the official data point type, which is specified by the KNX association. It's the data point type 18001, data point type scene control. So, and here maybe the explanation of our 8-bit scene telegram. So we don't transmit the value, we send only one command, call or store the scene. It depends here on the first bit. So when we call the scene, press short, and then the first bit here, which is the blue one, is always 0. And then the next bit is spare, is not used, and the last 6 bits are used for the number of the scene. So for example, when we call scene number 1, so call means the first one is 0, the next one is 0, and all 6 bits are also 0. This is the command on the KNX. When you record a telegram via the group monitor, then you see only the value 0. This means call scene number 1. When we call scene number 64, we have here still the first bit is 0, the next one is default 0, and then all 6 bits are 1. So you can see in the group monitor the value 63, then you know, okay, this is call scene number 64. And when we want to store a scene, then the first bit here is always 1. So when we press long, we want to store scene number 1, and then here the first one is 1, 0, and all other bits, the number of the scene is still 0, so we have the value 128 on our KNX bus. Yeah, or 199, which means the first bit is 1, store the scene, the second bit is always 0, and 6th time we have the 1, which is our scene number 64. So we here, when we get the value 199, 191, we have the command store scene number 64. This is so far the explanation of our 8-bit value. So like here in this example, we're using here DIM actuator, UDS, channel A default 50% ETA parameter, channel B 30%, switch actuator default off, on 50%, 10%, and here the height and the angle of the slats and lamella. These are all the default parameters. Now we have to set in the ETS per device. And we link all our devices via the same group address to our scene. Then we press here maybe the one side of the rocker. We call scene number 8 on our bits. On Telegram we have the data 7, and then all devices follow here exactly this value by sending only one telegram to all our thousands of KNX devices. Now when we press long, then we can store the scene. Maybe before the end user changed the value of the DIM actuator, he changed the position of the shutters, of the blinds, he switched some lights on and off, and then he pressed longer than 5 seconds, and then the device sends the value 135, sends this command store scene number 8, which is our useful data 135, and all devices knows, okay, I have to store now my value 50%. This is my new value for my output A. The next time when we call scene number 8, he have exactly these values, this situation in his building or in his room. So advantage of this 8-bit scene function to store it in an actuator is that we can call or store a scene with one telegram. We don't transmit the values. No command up and down or 50% or something. All these values are stored in our thousands of KNX actuators. We address only via one group address, all with the same group address, all our KNX actuators. Then we can use up to 64 scenes. When you want more than 64, of course, then you have to create another group address. Good. So far, let's go to the parameters of the sensor. At first we need a sensor which is able to send an 8-bit telegram, like for example, or today nearly all sensors, control elements, or here the comfort switch can do it. Set a parameter on the left side of the rocker. We use it here for light control, for light scene extension, and the parameters we set here the number of the scene number 8. So when we press short, he sends the command call scene number 8. And when we press long, because we have a storage function is activated, then we send the command store scene number 8. So for the other rockers 2, 3, 4, we want to call maybe here other number of scenes, scene number 23 or scene number 17, but all of these rockers are linked with the same group address. Because with one group address we can now call up to 64 different scenes. And then the actuators, we have also all the actuators to enable the additional function 8-bit scene. And then all these devices get automatically a communication object 8-bit scene. And we link all these communication objects with the same group address 1111. Like here in the switch actuator, channel A, channel B, channel C, or if you want channel D, when he should listen to the scene. In the DIM actuator, we have the same communication object 8-bit scene. In the DALI gateway, and for example here on the shutter actuator. So we need only one group address and link it to all actuators and to our sensor. And the next step is to go to all of our KNX devices, to the actuators, and set here the default value. For example here in a switch actuator we enable the additional scene function, and say okay, when there is a scene number 8, then he should go to the value on. Scene number 25, for example off, scene number 17 on. So per scene we define here the values of our channel A. And then the same channel B, channel D, E, F, and so on. Or here in the universal DIM actuator, the same. We enable the scene function and say when there is a scene number 8, go to the default brightness value, for example 83%. Or here in a shutter actuator, we can define the value, the position of the height, between 0 and 100%, and the position of the slats. So open or close the slats, maybe here up to 45%. And last but not least, in a Dali gateway, when there's a scene number 8, we can say group number 1 should listen to the scene, yes, with the value 66% or 50% or 90%, depends on your parameter settings. Good, and here's an example at the end of our scenes, like we have it, for example, in a typical residential building or apartment. We have here our dim actuators, switch actuators, shutter actuator, and of course the new KNX security panel. And now when we want to go to bed, we press here one rocker and call the so-called the good night scene. Scene number 4 is good night. So, and then, for example, our dim actuator, the output A, which is the light in the bedroom, is not linked, not assigned to this scene, for example. So the light can be on or off or dimmed 50%. When we call the good night scene, nothing happens. It does not listen to the scene command. But the output B, which is the light in the staircase, goes off. In our switch actuator, we have channel A, for example, the light in the kitchen, it goes off. The socket outlets in the kitchen off. Living room, the light off. In the bathroom, the light off. But the light in the children rooms, like here in the channel E, is not assigned, because the light can be on or off. We want not to switch the light when we call the good night scene, because when the children's reading a book, the light should still on. The same here in the shutter actuator, drives also in the position closed, 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 or here the lamellas, like you want. And the security panel follows the command, and our system goes internal set during the night. And in the morning, when you wake up, call the good morning scene, which is maybe the scene number 6. Some lights go on. For example, here the socket outlets in the kitchen, but all other lights are still off. The shutters and the blinds, the living room, bathroom drives in the position up, and the security panel goes unset. Good, so far a small example how to use the comfortable features of the scenes in an actuator. Next step, what we can do with scenes is a kind of sequencer. So for example, here a kind of cyclical light colors, like we have it maybe in a spa or in a wellness area of a hotel. We use the LEDs with red, blue, green, purple, yellow light, and we want to have that the color change automatically. So we can use here, a good example is the scene function. But we need additional logic, which can be our application unit, the ABL. So we define our different scenes, the color, the blue, the yellow, the purple, the green, and then via the additional hardware we start a sequencer which is inside our application unit, and then he calls our different scene. So we can also set here parameter, the transition and the scene runtimes, and we need additional push button to start or stop this sequencer. Like here we have the screenshot of the ETS. Parameterization of this application unit. We create here our scenes, we define the value, and then we need a 1-bit information. We call one scene. After some seconds he goes on, calls the next scene, the next scene, the next scene, and then he starts again at the beginning. Until we stop here via 1-bit telegram, and then the sequencer stops to call these different light scenes. Good, what else? Or the next nice problem is, for example, we have a 1-bit sensor, and we want to call a 8-bit scene. This does not work, because a 1-bit sensor can be our weather station, weather sensor outside. We have rain or we have no rain. This is not a one byte information, this is a 1-bit. So what we have to do, we have to convert this 1-bit telegram, the value 1, which means, for example, rain, into a 8-bit telegram, when we want to call our scene number 8, for example. How we can do it? We can still use the application unit logic. So in the application unit logic, we need one gate, and via the one gate we have one input, our control input. This is the information, for example, from the weather station, rain, yes or no. We use another input, which is a 1 byte, and here we set as a default value the value 7. And then depending rain or not, he sent this 1 byte default value to the output and converts so the 1-bit information into a 1 byte. So this is a nice feature to convert a 1-bit into a byte by using the ABL gate function. Good, next topic, status LEDs. So Here our control elements or our sensors, we have LEDs on the left and on the right side of our rockers. The LEDs can be green, red, yeah, for maybe which can show the actual status or the correct status of our output. Or for example, we can use here the color coding concept, like we have it, for example, and also in the push prion, that we use, for example, the yellow LED to show this is a rocker for maybe switching the light. Or when we use, for example, here the blue LED as the function to show this is one rocker for controlling the blinds and the shutter. Or, for example, the purple to call the scene. So here are only some examples how you can use the LEDs. There are maybe different more solutions. To use the red LED to indicate maybe there is wind alarm. Yeah, so the end user wants to drive down the shutter. If you press the rocker, nothing happens. So we can assign the group address wind alarm also here to the status LED object, and then the LED is on. Or also possible to flash the LED as an indication there is wind alarm. That's why you cannot drive down your shutter. So one solution is we use here the mode of the rocker and say on the left side we want to switch on the light, and on the right side we want to switch off the light. A very clear position, left on, right off, and then we can use the LED, the left LED, for example, to switch on the light, and the right LED, for example, the green one, to show when the light is off. Or we use the toggle function. Toggle means I can press here, left or on the right side. Every time we switch on and off and on, depending on the position which rocker we switch. Here the same we use when we switch on the light, for example. Both LEDs are red or both LEDs are green, which shows that the output is, for example, off. Or when we use the colored concept, then we use, for example, a left LED, which is the yellow one, to indicate this is one rocker which has something to do with light. And with the red LED, the right LED, we shows the output. Red, the output is on, or green, the output is off. So we use only for status the right one, and the left one is to show the function yellow, it is light, or blue, for example, something to do with the blinds. So, and many more possibility, depends on the on the requirements in your country. So how we use this status function, the correct way to use the status function. So for example, we have here one control element. When we enable this is a switch sensor, we get the group object rocker 1. We get the LED, the status for left, and the LED status on the right side of the rocker. In our switch actuator, or in all our actuators, it can be also dim actuator or our Dali gateway, for example, we have here our output A for switching, and we have one output for the status. So this status output shows always the correct status of our maybe relay position, for example. What does it mean? When we press here our rocker, let's do it. We press here our rocker on the left side. The rocker sends this group address 1321 with the value 1 to the KNX bus. The output A is linked with this group address 1321. The object goes to the value 1 and the light goes on. The next step, what happens? The switch actuator sends now a telegram to the KNX bus that he has a new status. So he responds with this group object 1324, send it by this object status switch to the KNX bus with the value 1, yes, I'm on. And then we have linked this group address here with the LED on the left side and on the right side, for example, also. And then this object here becomes 1 and shows, the red LED, the light is on. So here on this output A switch, the actuator listens to a lot of telegrams. Maybe it can be more, 5, 10 different group addresses, the central group address of the room, of the floor, of the building. But this output here, the 1324, this is always the correct status of the output. And we assign this object here via one group address here with our LEDs. That's the best way to use the status information. Okay, the next step. For example, we press here our central off push button, which is connected to the universal interface. And now he sent the command, the group address 029 with the value 0 off to the bus. This group address is linked with output A. The object goes to the value 0, the light goes off. Output B the same. And what happens? The actuator responds with this group address 1324 with the value 0, and the LED are here also linked with the same group address 1324 on the left and the right side, and the value goes here to green. So this LED shows always the correct status here of this output A. So it's a principle that we use this group address here, status, to show the correct information here on our LEDs. Good, next step, sending the first group address of a group object. What's behind? A group object, for example, of a sensor, control element, motion detector, can only send one group address. So you link your group address to rocker 1, you press this rocker, and then he sends this group address to the KNX bus. But here you can see you can still assign more than one group addresses to one group object. The ETS allow it. So for example, here I use the universal interface. I have here assigned two group addresses, 1511, 1514. When we click here on our group object, input A, telegram switch, we can see here both of these group addresses, including the names, 1511, 1514. And the first one here, you can see an S, the sending. It means when I close here this input, this group object sends the first group address, which is here the sending one, the 1511 to the bus. The other group address, 1514, cannot send to the KNX bus. This is a KNX specification that only the first group address, the sending one, now is sent to the KNX bus. You can change the behavior when you click, for example, on the other group address, right mouse click, and then the window pops up, set sending. So you can change and say, okay, now this address should be the sending one. Goodbye. But why it is necessary to assign here more than one group addresses? Sometimes it is necessary. When you see the next example. So we have again here one rocker. For example, set a parameter, left side of the rocker off, right side of the rocker on. Clear position, left off, right on. Here we have additionally a universal interface connected to a standard push button, and here we use the toggle or the alternating function. So now when we press, we want to switch on, next time off, on, off, on, off. So every time when we press, we want to change the position of the relay, switch on, switch off, the like of our actuator. So now you can see here we have linked the group address 1511 to the output A. And the first one here is the sending one. So when we press our push button, then he sends the command on, off to the actuator. And we have linked the group address, the status group address 1514, here also to this input A to update the information of our actuator. We need it, for example, here in this example. We press here our rocker. So before it was off, then he sent the command on, the logical one, here including the group address to the bus. The output A is listening, switch the light on, the object goes to the value 1, and the device responds here again with the status 1514, yes, I'm on, and the object is also updated. So the next time we press here the left side of the rocker, we send this group address 031 with the value 0 to the KNX bus. The output A is listening, the relay goes off, the light goes off, and the object goes to the value 0. And the actuator now responds with 1514 with the information 0 to send it to the KNX bus. Now I'm off, and and our universal interface is now updated. So the universal interface now is listening to the status information and knows, oh, the output A is now off. So because here you can see this object is updated. So the next time when we press here this rocker, the universal interface knows, before the other device has switched off, I must switch on. I must send a 1 to switch on the output. So this is why it's very important that he listen always to the correct status of the output. Then it's necessary to update the information when we assign here more than one group addresses. That's behind this feature. If you don't assign here the status address, the next time you press the rocker, he will send a 0, nothing happens, and then he will send a 1. So we have to press 2 times until you see a reaction in your KNX installation. If such things happen, please check maybe if your input here must know the correct status of your output. Good. So far, some words about couplers, not really in deep. I want to put a focus on the line repeater. You know the typical topology of a KNX installation. We have area couplers or backbone couplers. We have the lines. We can install also devices in one line. And additionally, under a line coupler, it is allowed to install up to 3 line repeaters. Line repeater and line coupler is the same hardware. The only difference is in the ETS settings. So when you use a line coupler as a repeater, you have to change the parameter. You are a repeater. And then the filter table is not used because a line repeater forwards all the telegrams from one line segment into another one. But the advantage is that we can have up to 3 line repeaters under one line coupler. So we can have up to 255 devices, yeah, in one line. So, and a line repeater gets always an address. Yeah, it must be under the topology of the line coupler. So, like here in our example, when we have the line coupler 110, then all devices must have addresses 111 up to 11255. For example, the line repeaters 64, 128, and all devices under this line repeater, maybe 129 to 191, like you want. It's not necessary to have here really a clear structure. You can use all addresses, individual addresses, or mix it like you want. But important, all devices must have addresses 11x or something. So, and the line repeater makes also a galvanic separation. That's why we must have here power supply in this line segment, and of course here in this line segment. The advantage is to use line repeaters that we can have here up to 255 devices, and all devices have the same address in the line, like area 1, line 1, and so on. So when you need such line repeaters, like here example in a small, for example, office building, we have 5 floors. We have so-called a west wing of the building and maybe here a east wing. How we can divide this building in area and lines. So we have 5 floors, and per floor, per wing, we have no more than 64 devices. Then we can say, okay, here on the left side, maybe this is the west wing, this is my area number 1. And here, the east wing, this is, for example, my area number 2. So we create here a topology 2 areas. So we need 2 area couplers. And here under one area coupler, we have 5 floors, maximum 64 devices per floor. So we install per floor 1 line coupler. And the first floor here is area 1, line 1. The next floor is line 2, line 3, line 4, line 5. And nearly the same on the other side, on the east wing. We have here area number 2 on the first floor, line number 21, next floor 22, 23, 24, 25. So we have a clear topology. West wing is area number 1, east wing number 2. But what happens when we have more than 64 devices per floor? Then we can do, for example, in this way. We create 2 lines per floor. Like here on the west wing. Line 11, 12, next floor, line 13, 14. So we have devices with different individual addresses here in one floor. So on the floor number 1, we have line 11 and the line number 12. You can do it, or say, okay, now instead of this one, we use line repeater. So we have here maybe the possibility to have 3 line repeaters. So all devices here in the floor number 1, maximum 255 devices, have the same address 11 something. The next floor 12, 13, 14. I think this is a good solution or example when we use these line repeaters. So now when we do diagnostic and we record a telegram which was sent by the device 138, then we know, okay, 1, this is the west wing, 3, this comes from the floor number 3. So then we can have here all devices with the same individual address range per floor. Or we use here the IP world, for example. Instead of twisted pair, we use here our IP router. Here the same 5 IP router, and use here again our line repeater. We can also install under one IP router up to 3 line repeater parallel, also possible. Good, some words about information about the local address of the USB interface, a quite common mistake. So for example, we have here installed our USB interface in the so-called backbone line. So here we have our 2 area couplers, area coupler 1, area 2, and here this line is called backbone line. So when we install here our USB interface, take care that the USB interface has the correct individual address. And now this address here is 00 something. So for example, the individual address or the local address of the USB interface must be 00, and we recommend to use the last one, 255. If not, then maybe you can get problems during a download. Yeah? The device does not respond, or the download stops or something. So in this case, before you start making a download or program a device, check the local address of the USB interface. Go back here and the ETS, the menu bus, and then you see here the current interfaces. Here you will see your USB interface, and then here on this field you can enter the new individual address, the local address, which must be the 00 and recommended 255. You can click here on the button address free, and then some seconds later you get information address is free, and this USB interface will get the correct individual address 00255. Or now when you remove the USB interface from here and you connect it to here, this one is my area number 2, this is my main line, 20, so all devices here must have addresses 20 something, so the USB interface must have the correct local address 20255. Or now when you go here, for example, in the floor number 1 in our east wing, which is the line 21, and then you have to change the local address of the USB interface to the address 21255. So be careful, check the line here, the addresses, and then change it here to the corresponding individual address. If not, then maybe you get a problem. Good, so the last slides about some planning information for safe installation. These are some recommendations made by the KNX Association. I would give you, for example, here some details. At first, when you use Wi-Fi or IP, like in public buildings, for example, the first step is you should use really complex passwords. Or you can use, for example, the MAC address filtering in your network router to say only maybe at home my iPad or my tablet or my smartphone with this MAC address have access, for example, to my Wi-Fi network when I want to operate my KNX installation via Wi-Fi. This is, for example, very important. And in public area, also try to avoid that unauthorized people have access to the KNX bus cable, like in the hotel room. In some hotels you can see the distribution board behind a picture on the wall, for example, or behind the entrance door. You can open it and you see the circuit breakers, you can see the KNX devices. In this case, this distribution board should be locked by a key so that no hotel guest has access to the KNX devices in the distribution board. And for example, also recommended to use no KNX control elements, no KNX sensors. So use standard push buttons and wire these standard push buttons to binary inputs. And these binary inputs are now installed in the locked distribution board. So when a hotel guest opens or removes, for example, the push button behind, he can see only the cables but no KNX bus. So, and of course, on the IP router on the KNX line coupler, we have some parameter settings, which is one that we can block physically addressed telegrams or broadcast telegrams, so that we cannot send maybe a download from one line to another one. That's why we use physically addressed telegrams. Or now when you use the security panels with KNX interface, like our ABB security panel GMA, then this panel must be operated in the unidirectional mode. So it cannot be possible by sending a KNX telegram to unset the system. Maybe the setting and unsetting, we do it via the security panel, the keypad. At first you have to enter your 6-digit PIN and then you can set or unset the system, but not via KNX. In principle you can do it via KNX, but if someone maybe has access, he can manipulate your system. And in some countries where you have problems with energy or when someone wants to manipulate, it's the best thing to use the KNX uninterruptible power supply. So when there's mains failure, the system is still working. And I hope you remember we have a special device which is so-called monitoring unit, the EUBS, and is a piece of hardware which, for example, checks the basic function and the presence of KNX devices. So this device maybe can send a command to a KNX device with the address 115 IOK, and then the device does respond. If not, then maybe the device was disconnected from the KNX, or maybe some changes or some malfunction. This monitoring unit can send alarm message to our visualization or to maybe SMS device or email program. So this is also a very nice device, the so-called monitoring unit, EUBS. So, but never install the KNX bus cable outside the building, because when the KNX bus cable is outside, an attacker, maybe can make a short circuit, put the red and the black cord together, and your complete line now will be dead. So nothing happens in this line. So, and for example, when he has still access to the KNX bus cable, he can connect his USB interface and can read out, for example, KNX devices. When he has the reconstruction tool, he can read out all the parameter settings, the group addresses, and can create a new project and manipulate. And of course, he can download KNX devices, download a device with no group addresses to manipulate, for example. Or he can record the bus traffic via the group monitor and analyzes the telegram. When he knows, okay, this is a telegram maybe for some special features, for a special scene, a goodbye scene or a welcome scene, and then he can also manipulate and send the telegram. And do not forget, when you install KNX cable, you need additional lightning protection measures. It's also required depending on your local country. And when you install KNX devices outside the building, they are not specified for this outside temperatures and humidity, for example. And when you install a standard KNX controller element outside, and now the heavy rain goes inside the KNX device, also a short circuit can cause. Or the device sends undefined telegrams, and you are wondering what happens in my KNX installation. So the best solution, or our ABB solution we use or recommend is, for example, never go with the KNX cable outside. Use, for example, our weather sensor, the WES, which is installed outside. And inside the building, in the DB, we have our weather unit. And the communication between the weather sensor, the weather unit, is only internal communication. So when outside someone manipulates the weather sensor, it does not affect our KNX installation inside or the weather unit. Or for example, when you want to use push buttons outside or motion detectors, movement detectors, use the conventional with, for example, IP54 or IP66 and connect all these devices via cabling to the binary input, which is installed inside the building. So outside, you can attacker can manipulate. It does not affect our KNX installation. So for more or for further important information, the KNX Association has launched some papers. One is a security checklist or the position paper. We will send also you the download link in our feedback email, and also ABB we have here a small guide, the so-called ABB Smart Home Guide for network security in building and system controls. We will also send you in our feedback email this the link, and you will get some more information about IP and security at home in your building. Good, so far near the end of this webinar, I would like to give you information about our KNX training here in Heidelberg. We offer the next training or next trainings here in Heidelberg. One is our KNX Certified Advanced Training from the 11th to 15th of July. This is the official KNX Certified Advanced Training with all the topics: HVAC, security, light control, logical operations, application unit, and a lot of things. So we do also a lot of practical work. Some spaces are still free, so you or your customer can come to this training. It's from Monday to Friday here in Heidelberg. And at the end, you get also the official KNX Advanced Certificate. So for ABB colleagues who wants to become a KNX tutor, now we have a special tutor training in October. And our security panel, the GMA, we offer also a special training next month from the 20th to the 24th of June. Is also some seats are still available, and in this week we talk about KNX and security, also with security terminal, security module, but we put the focus on this KNX security panel. And also we offer some various courses depending on your local country, so in these cases please ask your local sales manager. Good, I think we are at the end of the webinar. It's a 4:15 here German local time. Sorry for being a little bit delayed, but see, there's a lot of topics today. I would like to introduce you the next webinar. The next webinar will take place on the 15th of June. So the same time, morning 9 o'clock and the afternoon 3 o'clock German time. So, and we will introduce you the new device, the so-called Push Control Touch KNX. not only the hardware. You see here on top there's a piece of hardware connected to KNX and connected to IP. So, but all things what you can do, for example, numerous function, and additionally the ABB Living Space Portal, how for example we do the parameterization of this visualization. It's not only slides, so really we show you in a real installation, or my colleague Ilya Sidanovic will do it, how you for example get all this data from the ETS in this Comfort Touch and how you can operate here via a smartphone or via tablet a KNX installation, including for example network cameras and such things. Good, so far I think we have at the moment no questions. So I think let's come to the end of this webinar. Thank you for taking part and again your attention. I hope Thorsten and me to see you or to welcome you again on the next webinar on the Wednesday of 15th of June. Of course you get invitation letter, but remember the date. Yes, okay, thank you. Have a nice day. Goodbye to all and until the next webinar. Goodbye.
Yeah, thank you. Bye bye also from my side. Ciao.